This video is our feature and system demo for a SCADA robot mechanical system. This video will have three main sections: mechanical, electrical, and control part. I will start with mechanical part. The first part in mechanical part was motor selection. After considering constraints and requirements, our main goal was reducing the weight and maximizing the torque in a way that we wanted to use gears. Moving on to our assembly and SolidWorks and stress analysis. We decided to use PCB rigid for our arms so that we will have lighter design, but we are using steel for our base, which makes it more stable. Also, we built a housing for our PCB board. Our gripper function in a way that three links are connected to each other, so that we won't need to use gears for its functionality. And all this design satisfied a stress analysis. Our last part was simulation X, and our main goal was reducing running time and also designing a gripper in our simulation X that has the same behavior as our SolidWorks. Here is our co-simulation result, which satisfied our desired result. And here is our overall RCG criteria, and we satisfied all requirement and constraint, and our main goals, which were minimizing working volume and minimizing the cost.
For the electrical part, we had main two requirements. So one was to rotate our motor in both directions. As you can see here, we have inspired from the layout of an H-bridge. We have used two P MOSFETs at the top and two N MOSFETs at the bottom. So this way we make a voltage difference of 24 volts, and we can rotate our motor in both directions. And the other requirement was to integrate all of the components in one PCB. So here, this is our PCB, and you can see all of our components over here, and we have our fuse over here, which protects our motor from any overcurrent that can happen. And these are our bypass capacitors, which are connected to power supply and ground pins of our op-amps to reduce the noise caused by the power supply.
For the control part, we design and turning the PID controller to achieve RCG criteria. We have 3.5 degree of freedom, and we only use one Arduino controller, and we also minimize the cost and minimize the footprint, and also our system is stable. And this is our Simulink model. The output of the model is this one, so which is stable and the same as expectation. And then the next step is to implement it in the simulation X. So here's the video. You can see that the system is very stable, and there is no overshoot before gripping the marshmallows, and it can go 3 different locations and grab the same size marshmallow and drop it in the garbage can. And this video is more than 20 seconds, but the actual processing time is 6 seconds. We slow down this video. And the clever design is the input. We use multiple step input system, which has 6 step block, and each step block has different step time, and each two of them are in pair. They have opposite amplitude, which means when the process is done, when each process is done, it will output 0, so it will not influence other branches. And then these 4 pictures is the output from the Simulink, which is match the sensor in the simulation X. You can see that the red line is angle position, and the second and third one is a little bit greater than previous one because the arm gonna rotate more deeper than the previous one, so that it can go different locations and grab the marshmallows. So that's all for our project. Thank you so much.